Hi viewers, welcome to LMS Solution. Today we are going to see about microgrid dynamic operation with different MPPT. That means this microgrid consists of PV array and battery storage, and it going to be connected to the grid. Okay, so this microgrid consists of PV system. Okay, so normally in order to extract the maximum power from the PV, so we will use MPPT algorithm. So MPPT nothing but a maximum power point tracking algorithm. So here we are going to vary that means we are going to use different MPPT method, and we have to check the result of the microgrid. So here we are going to use P&O in PPT, and then we have to use PSO ANFIS MPPT, and then we have to use PSO sliding mode MPPT. So we are going to use 3 MPPT, and then you have to compare the result of the 3 MPPT. And first of all, I am going to explain that the system. Okay, so this is a system. The PV array or PV plant, right? The total rating is around 1 megawatt. So here you can see that. So this is a rating of the PV panel. That means here you can see that the PV panel rating is 355 watts, and then it have 15 panel in series, and totally it having 190 parallel strings. So when you click this plot, right, you can see the IV PV characteristics of the solar PV system. So here you will see that around it will be generated 1.01 megawatt. Okay, at that peak power voltage around 651 volt at 1000 watts per meter square irradiation. So you can see the different power level for different irradiation. Okay, so it can generate maximum of 1 megawatt when that irradiation and temperature at a standard test condition. That means irradiation at 1000 watts per meter square and 25 degrees Celsius. And then here they are using boost converter. So here the boost converter used. So here the boost converter used to boost the voltage, and then here the 3-level inverter, that means neutral point clamped inverter used for converting DC to AC. And this boost converter going to be controlled by means of MPPT algorithm. So here you can see that. So you have two kind of control. So just you have to concentrate on that MPPT. So here we are using MPPT algorithm. So here that MPPT algorithm used here. So here you can see that this is a P into MPPT. Okay. So P into MPPT will receive voltage and current. So based upon voltage and current, you have to calculate change in power, change in voltage, and then based upon change in power, change in voltage, we have to calculate the duty cycle. Okay. So that will be happen in the P into MPPT. And so output will be duty cycle. Okay, so this output will be taken from that here. Okay, so it going to be control this boost converter. And then here you can see that PV inverter control. So you have to measure point of common coupling voltage and current, and then DC link voltage, and then reference voltage. That means reference voltage across, that means what's the voltage should be maintained across this inverter. Okay, so when you go inside, right, you can see that different detail, right. One is voltage regulator, another one is PLL, that means PLL and power transformation. So here we are converting that means converting that actual ABC quantity into VDP quantity by using power transformation. And then here we are using a voltage regulator. It's an voltage regulator. Here we are comparing that means reference voltage and then DC link voltage, and it going to be processed via PA controller. And then the final output of this voltage regulator is nothing but ID reference. And then here we are using only ID reference control. That means we are making IQ reference equal to 0. That means we are going to send only real power from the PV to point of common coupling. And here you can see here, right, after that So this will be given here, IDIQ reference. Already we converted that IABC into IDIQ by using part transformation. So then here that we are applying that feed forward decoupling control concept. So by applying feed forward decoupling control concept, we are using that current regulator and feed forward decoupling control concept to generate the VDVQ. So after generating VDVQ, we are going to convert it into actual form. That means ABC form by using inverse part transformation. So finally, you will get that V reference in the that in control voltage in the ABC form and going to be process VAPW generator. So that going to be control this neutral point clamped inverter, okay, for converting DC to AC quantity, and then whatever power generated from the PV, so that going to be injected to the point of common coupling, okay. So this is a solar plant detail. So next you have to see about a battery plant. So here, so it have 1 megawatt battery system, and then it can supply maximum 1 megawatt hour, okay. So rating of the battery here you can see that 922 volt, and then nominal capacity is around 1 megawatt hour, okay. And then SOC of the battery initially is fixed at 50. So next here that we have that 2-level inverter, okay. So here we are not using any converter, so just you have to use only, that means that battery is directly connected to the inverter. So just you have to convert DC to AC or AC to DC according with the condition of control logic, okay. So whether we go for charging or discharging, or so based upon that converter going to be act like a converter or a inverter, okay. And then finally it going to be connected to the point of common coupling here. So here you can see that control of inverter, okay. So this is a control of inverter based upon active power control and reactive power control, okay. So next thing is here you can see that this is a local load, and then so here it's the grid system. So this point of common coupling voltage will be 600 volt, and then going to be step up to 25 kilovolt, and then it's connected to the grid 120 kilovolt grid, okay. After that here also we are step up the voltage from 25 kilovolt to 120 kilovolt, and overall system will be operated at 60 hertz. So here you can see that you can measure the point of coupling voltage as well as you can measure the frequency of operation, okay. So this is the overall system, and then you can measure the detail here. That means you can measure the detail of point of common coupling power, load power, battery power, battery, that means power from the battery energy storage system after inverter, and then power from the PV as well as the reactive power from the battery side, okay. So here you can see that detail, and also you can see the point of common coupling current, load current, and battery side primary current, and the PV side primary current here, okay. You can see that the results. So here only we are that means after simulating the model, you have to compare the result of this PV power with the other MPPT also, okay. So next time I'm going to discuss about PSO MPPT. So here I'm going inside, right. So here we are using that PSO MPPT, okay. So here you can see that we are using fuzzy structure. So the fuzzy structure we have created based upon PSO tuned ANFIS concept. So input will be irradiation and temperature. So output will be voltage, and it going to be compared with the PV voltage, and again going to be processed with PA controller. So it will be generate the duty cycle, okay. So finally this duty cycle going to be sent to that boost converter to extract the maximum power from the PV panel. So and also here we have that code. So this is a PV model, okay. So this is PV model. So whatever model used in this, right? So you have to take that reading, then you have to take the specifications here, right? So here you can see that we are taking 8.68, that means. So here you can see that short circuit current, current at maximum power point, open circuit voltage, voltage at maximum power point. Okay, and also you have to take the detail of temperature coefficients, and then you have to generate the random irradiation temperature data, and then we have to collect the voltage. Okay, so once you execute this one, and this code automatically execute that PSO ANFIS training model. So finally you will get the fuzzy inference system. So that after training of this data by using PSO, so you will get an ANFIS structure in the form of fuzzy inference system. So we have to use that fuzzy inference system inside that MPPT block. Okay, so this is a concept. So we are using that PSO ANFIS. So you can watch my YouTube videos. Already I made some video about PSO ANFIS MPPT. So you can check that video also. You will get a clear idea about that one. Okay, so here we use that model. Okay, so here you can see this PSO ANFIS code. So first we have to run this code, after that it will be execute this code. Okay, so inside you can see that this will be trained automatically. Okay, so training process, everything will be happen. Okay, so next you can see that once again. Yeah, so here you can see this is the main code for ANFIS training. Okay, so PSO used to for training that ANFIS. So after that finally you will get a final ANFIS structure. So this one the ANFIS structure created from the that code, right? PSO ANFIS code. So that detail will be used inside, right? So here you have to use that inside the detail after training process. Okay, so next we move on with the PSO sliding mode control. So here also we are changing the MPPT method here. Here you can see that. So here we are using PSO. So the PSO will be generated the reference voltage. Okay, so the reference voltage going to be processed via sliding mode controller. So this is sliding mode controller, and the sliding mode controller will be generated the duty cycle, and then the duty cycle going to be control this boost converter. Okay, so first we need to load the data once again. So now I am going to simulate this one. So PSO ANFIS MPPT, I am simulating this PSO ANFIS MPPT. So here you will see the results, and also here you will see that voltage at point of common coupling. Okay, and also here you can see that frequency at the point of common coupling with PSO ANFIS MPPT. So it will take some time for completion, so we have to wait up to completion. So now you can see that right simulation is this comes to end, right, for PSO ANFIS MPPT. So this is a response we are getting from a PSO ANFIS MPPT. So here you can see it's a response of PV system power generation. Okay, and then here you can say this is the load power. So this is point of common coupling power. So this is a reactive power from the battery side inverter, and then this is the power of battery side. Okay, so this is for a ANFIS MPPT. So next move on to P and MPPT. So here I am going to execute that P and MPPT. So here I am going to execute that P and MPPT. You can see the result here. So now you can see that the simulation started for P and MPPT. So it will take some time to complete. Okay, wait up to completion of simulation. So now you can see that simulations almost come to end of the 5 seconds. Okay, so this is the result with the P and O MPPT. So next move on to the result with the here we come PSO sliding mode MPPT. So here I am going to simulate this model. So it's compiling the model, so it will take some time to complete the simulation. So simulation is not yet started, so you have to wait some time. Now you can see that the simulation is started now. Okay, so it will take some time to complete the simulation. Okay, so now you can see the simulation is almost completed for a PSO sliding mode MPPT. So now I am going to compare the result of first you have to take the result of PSO ANFIS, and then I am going to take the result of PSO ANFIS, and then I am going to take the result of PO MPPT. Okay. So this is result of ANFIS, result of PSO sliding mode MPPT, so result of PO MPPT. So here I am going to take a print to figure, and then I am going to take only the PV detail, and then I am going to create new figure, and then I am going to paste here. Okay, so this is for ANFIS, so I am going to change the color to red. Okay, red indicate the result of ANFIS. The same way I am going to click the result of PSO sliding mode MPPT and print to figure, and then I am going to click that PV result alone and copy that one and paste here, and then here I am going to click result of P and O MPPT, print to figure, and then I am going to copy this result. So before copying the result I am going to change the color to pink and copy that result and paste it here. So now we can see the result of PSO ANFIS and PSO ANFIS and PSO sliding mode MPPT. So from that result you can see that the PSO MPPT will, that means that they are providing the better results. So here you can see that, so PSO ANFIS providing the better tracking in MPPT. Okay. And also here you can see here, right? So here also see here that PSO MPPT will take a long time, right? They have some problem in their tracking. So PSO ANFIS is providing better result. Okay. So from this result analysis, right? So we can conclude that the PSO ANFIS MPPT providing the better result than PSO sliding mode and PSO MPPT. So thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.